Welcome to the deep dive. Today we're looking at cosmology and asking a pretty fundamental question. What happens when our two best ways of measuring the universe just completely disagree?
It's a huge problem. I mean, for decades, we've had this story, the ACDM model, and it's worked incredibly well.
The standard model of cosmology, right?
Exactly. But now, the cracks aren't just showing, they're becoming chasms.
And these aren't small rounding errors.
And not at all. These are what we call tensions. The biggest one is the Hubble tension. You measure the expansion rate from the early universe, the cosmic microwave background, and you get one number.
Okay.
Then you measure it today, using things like supernovae, and you get another number, a
Yeah.
faster one. And the error bars don't even touch.
That is profound. I mean, that alone tells you something fundamental is missing from the physics. But then there's the other problem.
The early galaxy problem, yes. The James Webb Space Telescope is finding these huge, mature-looking galaxies so early in the universe that, according to our models, they just shouldn't have had time to form.
It completely breaks the timeline. So what's the response?
Well, the response is pretty radical. Instead of trying to patch the old models, some cosmologists are saying, let's just throw it out for a minute.
Throw it out.
The assumptions, at least. They call it the empirical first workflow. You forget about the Big Bang, dark matter, dark energy for a moment. You just build a new story from what the telescopes literally measure.
Wait a second. How can you throw out something like dark matter? Don't you need it for gravity to even work at a galactic scale? That just sounds like scientific anarchy.
It sounds like it, but it's really about accountability. It's data before doctrine. And by doing this, by starting from scratch with just the observations, they've generated three completely different but internally consistent explanations.
Okay, so three new frameworks. Let's dig into them. What's the first one?
Framework A is called the embedded system. It proposes that our universe isn't a closed box. It's an open system that's sort of equilibrating with a much larger timeless environment around it.
Like a pot of cooling soup on a huge countertop.
In a way, yeah. And our cosmic expansion is just the universe settling down into balance with this outside environment.
So how do you test that? What's the smoking gun?
It makes a very specific prediction that the giant voids in space, the parts we think are empty, shouldn't be. There should be a very faint but detectable fog of hydrogen atoms.
So finding hidden hydrogen and then nothing would prove it. Okay, what's the next theory?
Framework B is the geometric phase. This one's a bit more abstract. It suggests that space-time itself is uncurling from a higher dimensional state.
Uncurling, like a crumpled piece of paper smoothing out.
Exactly. And the expansion we see is just that geometric process happening.
The visual evidence for that must be incredible.
It is. It predicts that the cosmic voids shouldn't be perfect spheres. They should be slightly stretched, like cigar shapes. And what's more, they should all be aligned in a preferred direction across the entire universe.
A cosmic alignment. That would be unmistakable. Okay, what's the third one?
Framework C is, well, it's the strangest. It's called the information unpacking. It imagines the universe began as a maximally dense state of pure information.
Like a cosmic zip file.
That's the perfect analogy. And cosmic expansion is simply the universe decompressing or unpacking that information over time.
That sounds like it breaks all sorts of rules. How does that model predict anything testable?
It predicts a hard boundary, an absolute edge to what we can see. It says there's a maximum redshift cutoff. No matter how powerful our telescopes get, we will never find a galaxy beyond, say, a redshift of 50 or 100.
A real wall at the beginning of time.
A hard stop, yes.
So the really crucial part of all this is the speed, right? We're not waiting for decades to figure this out.
No, this is happening now. They're launching a 24-month AI-accelerated research sprint. They're feeding over 100 petabytes of existing data from JWST, Euclid, all of it, into machine learning systems.
To try and break these theories as fast as possible.
That's the whole point. This is a new way of doing science. It's not about proving your theory right. It's about designing the observations that will destroy your best ideas. You force the data to choose.
Data before doctrine.
Exactly. The universe will tell us which story is right, not the other way around.
So that's the final question then. Over the next 2 years, which of these wild predictions gets confirmed, or more likely, falsified first? The hidden atoms, the aligned voids, or the absolute edge of the universe? It's going to be the fastest revolution cosmology has ever seen.